Today, the current industry standards for prompt engineering still, sadly, rely heavily on process oriented templates and rigid markdown formatting. This approach rests on the assumption that models execute logic like traditional procedural software, reading top down instructions and parsing bulleted rules. Inside the model, formatting symbols dissolve. Large language models operate entirely within a probabilistic web of word relationships. Physical layout carries no weight by the processing layer, structure evaporates, leaving only token relationships connected by mathematical weight. Applying a restrictive low-density vocabulary to this web creates a bottleneck, restricting the model's reasoning to shallow mathematical connections. High-fidelity AI control stems from semantic precision, choosing specific tokens that activate more specialized regions of the model's training data. It requires three pillars: vocabulary density, deep cultural literacy, and strict grammatical structures. Mastering these triggers allows a prompt architect to work within the model's internal probability map, accessing far more sophisticated analytical outputs. The weak version of the Sapir-Whorf hypothesis asserts that the language humans use shapes and constrains their cognitive perception. While linguists debate this concept in humans, it is a measurable reality within large language models. Consider this comparison. On the left, a low vocabulary prompt like write a short summary of this report triggers a wide diffuse cluster of generic data. Using generic words mathematically limits the model to its most predictable high probability data clusters. On the right, we use a high vocabulary alternative, distill this report into an incisive executive brief. Adding the tokens, focusing strictly on macroeconomic indicators, locks the AI into the advanced semantics of finance and analysis. The resulting outputs from these two different statistical pools will vary significantly in depth and technical accuracy. The specific tokens used in a prompt function as the actual borders of the AI's active data pool. The standard approach to prompting uses multiple sentences of process constraints to define how the model should behave. A typical marketer prompt reads, "Act as a marketer. Look at this text. Rewrite it to sound exciting. Do not use jargon." This relies heavily on conversational filler. A cleanse exercise removes these isolated and bloated constraints. Phrases like act as and look at this consume processing space without adding semantic value. In their place, we use high density tokens. Audit this text, eradicate platitudes and ossified corporate jargon, refashion the copy into a compelling visceral narrative. The token count drops, but the concentration of meaning, the semantic density increases, providing the model with a more specific target. Effective AI control is found by condensing these process blocks into precise high density vocabulary. Beyond word choice, syntax dictates the programmatic flow of token generation. Specific parts of speech act as mechanical switches within the latent space. Precise verbs like synthesize, juxtapose, or extrapolate command explicit mathematical actions, routing the processing flow down specific analytical lanes. Nuanced adjectives further calibrate the output. Describing a response as mercurial, pedantic, or sardonic shifts the stylistic probabilities toward a specific intellectual tone. During long generations, models often experience drift, where they slowly lose their initial constraints and revert to a generic average. Formal syntactic limiters like notwithstanding or contingent upon can help mitigate this drift, and these limiters function as logic gates, blocking high probability but incorrect mathematical pathways before they can form. This grammatical gating is a more precise method of control than listing do not do this rules, which the model may ignore during long outputs. Grammatical precision provides a mechanism for establishing a hierarchy of durable constraints that guide the AI's logic. Explicitly detailing every behavioral boundary of an operational framework often leads to wordy, inefficient prompts. The cultural toolbox leverages the vast libraries of literature LLMs absorb during training. Using established archetypes as semantic shortcuts, a single philosophical or mythological archetype can configure complex behavioral patterns, instantly acting as a high density shortcut for the model's weights. Invoking Socratic pedagogy commands the AI to guide users through diagnostic questioning rather than simply providing answers. A Machiavellian prompt triggers pragmatic, power-driven metrics, while a Kantian prompt shifts the model toward universal ethics and moral duties. An Apollonian prompt demands strict order, symmetry, and logic. A Dionysian prompt commands an analysis that is fluid, emotional, and deliberately chaotic. By leveraging cultural literacy, prompt architects bypass lengthy instructions by invoking the concentrated statistical weight of human history already present in the model. As we have seen, sophisticated prompt architecture relies on vocabulary density over structural complexity. Process-oriented templates and rigid formatting often function as a substitute for an understanding of how these spaces actually operate. Effective engineering requires three things: commanding vocabulary, deep cultural literacy, and a deployment of grammatical logic gates. Mastering these elements allows an engineer to navigate the probabilistic web of a large language model with higher precision. Moving beyond simple templates to work as a semantic architect allows for a far more direct, nuanced command of AI reasoning.